Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the SQL Channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PL/SQL developer just like you. This lesson is part of my series on writing dynamic SQL in Oracle PLSQL, and this topic is Method 4 Dynamic SQL, just about the most complicated thing you'll ever do in the area of dynamic SQL. So, Method 4 Dynamic SQL, what the heck is that? So method 4 is the most dynamic and most complex. There are two basic possible scenarios. Number one, at the time you compile your code, you don't know how many expressions will be in the select list of your query. So in other words, you might be selecting 2 columns, 25 columns. You just don't know at the time you're writing your code, which essentially means you need a dynamic into clause. Second, at the time of compilation, you don't know how many placeholders will appear in your string. :ABC, :DEF, every placeholder needs to have a variable bound into it so that you can either send values into the string or retrieve values from the string. So in this case, you need the dynamic using clause. But execute immediate, native dynamic SQL's major statement for executing dynamic SQL statements, has into and using clauses that are not dynamic, they're static. At the time you write your code, you have to specify how many elements you're either fetching into or binding into or fetching out of the string. So in general, when I have either one of these scenarios, I don't know how many things I'm selecting, I don't know how many things I'm binding in, you can't use execute immediate, and we need to take a look at using something else. And that something else is the DBMS SQL package. It's probably one of the biggest, most complicated packages, and that's why for all the other forms, methods 1 through 3, dynamic PL/SQL, execute immediate is definitely the choice that you want to take, the approach you want to take. But it does too much for us, and it does it implicitly. So we have open cursor, it binds our variables with the using clause, it executes the SQL statement, it retrieves the values into, it closes the cursor. It simply does too much because we need more control over these different operations. For example, how many things are we binding? How many values are we retrieving? We don't know this at compile time. So basically, we can't use execute immediate, and we need to switch gears and learn about and use DBMS SQL. Now, this lesson is not going to provide you with a detailed training on every element, every aspect of DBMS SQL. This is a package you're going to run into quite rarely and only really for this one purpose. So I'm going to focus on several different examples that demonstrate the kind of code you'll need to write for DBMS SQL Method 4. And here I'll give you a quick guide to the most important subprograms to know about. But there are many, many more. You can certainly check out the Oracle documentation or my book, Oracle Built-in Packages, which covers DBMS SQL in depth. So before you can do anything with DBMS SQL, you have to open cursor. You have to call the open cursor function to allocate a handle to a cursor. And a DBMS SQL cursor is an integer pointer essentially to a set of data. Define column is used to define an individual column in your dynamic query. Even though Oracle is parsing the SQL statement and therefore it can understand how many elements are in the list, you still have to define the data type of each column. Next, you're going to parse the statement so you can make sure that your SQL statement is valid. And bind variable, if you need to bind a variable to a placeholder, you'll call the bind variable program. You execute the statement, fetch one or more rows, retrieve the column value, so I fetched a row, now get my individual values. And whoops, though I didn't put it here, sorry, there's also a close cursor. Close the cursor when you're done. I should add that in there. Sorry about that. So these are just a small part of the many, many subprograms in DBMS SQL. Like I say, it's quite complex. You can do an awful lot with it. But the main thing is to make sure you understand these basic steps involved for method 4. And what I'm going to do is basically run through some examples. And the first one I'm going to show you is a dynamic select star from table, essentially doing the same thing that you would do with a select star from table in SQL Plus. Show me the contents of your table, doing it in PL SQL instead. Which means you provide the table name, you can provide a where clause, the schema name, and I'll display all the data in that table. Obviously, I don't know in advance which or how many columns will appear in my list. So this is an example of method 4, dynamic SQL. Give me any table you want, I'll retrieve the data, and I'll show it to you. So the question then becomes, in general, with dynamic SQL method 4, how do I know how many columns I've got and what their types are? In this case, it's a relatively simple case. I can obtain the column information from all tab columns, a data dictionary view that contains the information about columns in a specified table. Another approach you can take is to use describe columns in DBMS SQL, which is covered in the separate advanced features lesson. So check that out. If you don't have access to the individual columns in your list, and you don't have something like all tab columns to retrieve the data from, that'll be an alternative. This is also, because I can get my columns from all tab columns, it's a relatively simple example to use as a starting point. So let's walk through the basic pseudocode flow, the basic steps you have to run through with DBMS SQL. Then we'll take a look at the code. But actually first, why don't I show you the program in action? So it's called the in tab procedure. Let's pull it up. So in tab, pass in the table name, pass in the where clause, pass in a filter on the columns. So I can say we'll only retrieve the columns that have the phrase underscore ID in it. Let's compile this program and let's try it out. Well, I'm going to do something simpler than all of this. I'm just going to say, for example, show me departments. I'm going to grab this code and I'm going to run it in SQL Plus because it's a lot easier to see the formatting. So let's run this block of code. And notice, there's all the data in my departments table, nicely lined up. I'm really impressed by how I got everything to line up. That's actually the hardest part of the program I'm going to show you, and I'm not going to focus on that. We'll focus on the dynamic SQL part of it. So there's all the data in the departments table, and I could change this to another name, like locations. And I run this code. And now we see the locations. Clearly, different table, different columns. My program is able to figure out which columns there are, how many columns there are, and then display the information. So this is an example of dynamic SQL method 4. Okay, so let's go back to the overview, the flow, and then we'll take a look at the code in more detail. So here are the basic steps I have to go through. First of all, I have to construct my SQL statement so I can parse it. So basically for every column in my table, I'm going to add the column to a select list. I'm going to build A, B, C, D, add the where clause as necessary. Then I'll parse the statement for the cursor that I've opened for that select string. And DBMS SQL native basically says use the native features of the language, the current version. Then I have to define each column before I can execute. So I've parsed it. It's a valid SQL statement. But before I execute, I actually have to tell Oracle what my columns are, how many there are, and what their data type is. Then I can execute the query. And all that does is essentially identify the rows and columns, the set that I'm going to retrieve for this query. Then inside a loop, I'm going to fetch the next row. And while I'm not done, for every column in my table, I'm going to call column value to retrieve the value at that location. So as you can see, lots and lots of detail, many steps. But this is exactly the level of detail I need. Since I don't know how many columns I've got in advance, I need to call define column in a loop. Since I don't know how many columns I have in advance, I need to fetch the column values one by one inside a loop. There's no way to do this with execute immediate, but I certainly can do it with DBMS SQL. So here's a case where the complexity of DBMS SQL, which usually works against the value of using the package, and is the reason that Oracle introduced execute immediate. That very complexity is exactly what we need and what is welcomed for Method 4 Dynamic SQL. So let's take a look. It's a fairly large program, over 400 lines. I'm obviously not going to go through every detail of this, but as I mentioned earlier, a lot of the code here has to do with formatting the columns, figuring out how wide each column should be, and then formatting the results. That's not particularly of interest for you from a Method 4 standpoint, so I'm not going to go into the details on that part, though you're certainly welcome to explore all the details over and over again. So, out of my 400 plus lines of code, notice that my main body of code is just 5 lines long. It's essentially a table of contents. And I accomplish this by using local subprograms. So each of these programs are defined inside my main program and allows me to hide the details and make it really easy to understand and read this code. So first I'm going to load the column information. Next I'm going to construct the query and then parse it. After that, it's time to define my columns and execute my statement. Then I'm going to build and display my output, which has to do with fetching the rows and then retrieving the column values. And finally, I'll do my cleanup. So let's go through these. So here's my cursor. It's an integer, and I simply call DBMS SQL open cursor to allocate that handle for me. And that basically says this is my results, that this is my SQL area for this particular operation. And I always reference any call to DBMS SQL includes this cursor, so DBMS SQL knows which cursor, which result set I'm working with. Then as you can see, there's lots to do with formatting, lengths of things, figuring out which type it is. You have to know which type of data your different columns are. And basically what I'm going to do is just check for strings, numbers, and dates for a variety of data types. Clearly this is not a complete implementation, and it's very hard to do really complete implementations for any type of data, any number of elements, and so on. Okay, so I need to load my column information. Again, this is the part where it's highly varied based on your requirements and what information is available to you. Since I'm specifying the table, or the user is specifying the table, I can reference the table and check for that column filter list, of course, and get all the columns for that table. And I'm going to bulk collect them, retrieve them quickly into my array of column information. So gcolumns is defined as a list of all tab columns rows. So that basically lets me dump out the column information. Again, if you're not using something or don't have access to something like all tab columns to get your column information, you're likely going to be using DBMS SQL.describe columns, which is covered in advanced features. Okay, so I've got my columns. And then I'm going to run a bunch of code to calculate the size of my columns. But most importantly, so here's my loop through my different columns. Most importantly, what I'm going to do is build my select list. So add comma and then the column name over and over and over again to build my select list. And then I'm going to construct and parse my query. So I'm going to add a where clause. If somebody's provided a where clause string, if it's not null, then I'm going to put this information onto in my where clause variable. And note, this could lead to problems regarding SQL injection. This is covered, the SQL injection topic is covered in best practices. Then I construct my query. Well, it doesn't get more generic than this, does it? It's a select statement. Here's my list of elements I'm selecting from my table for a given where clause. Wow. Very, very generic. But okay, I constructed this from my list of columns, my where clause that's provided by my user. There's my query. So the next step is to parse it. So I pass in my cursor, I specify my query, and native behavior. Native, or this third argument, is something that was an issue back when Oracle first released Oracle 7. So you could specify you wanted Oracle 6 behavior. But there's really no reason to do any of that now. Just specify DBMS SQL.native. So I parse my query. Great, assuming there was no error. And now I can move on to defining my columns and executing. So basically, before executing the query, I need to tell DBMS SQL the data type of each of the columns being selected. So for every one of my columns, if it's a string type, I'm going to define, here's my define column program. I pass in the cursor, the nth column, the type of data and the length of the data. At least for strings, I have to provide the length of the data. If it's a number, I specify cursor, the index, and a number value. Date, I specify a date value. This is a very interesting kind of overloading. Basically, it's using the type of data to determine which of the defined program overloadings to call, defined column overloadings to call, and then setting the appropriate information internally. I could have done something like define column. The nth column is a string, literally passed in the name varchar2, but that's not how this works. You pass in a piece of data of the matching data type, and then Oracle uses that information to say, okay, that's a string, the second one's a number, the 15th is a date, and so on. Clearly, my implementation only works for strings, numbers, and dates. So if you want to extend it to support other things, you'll have to do that yourself. Okay, so I define each one of my columns. Now I'm ready to execute. So I execute the statement. Now, if this was a DML statement like update, insert, delete, then I can immediately get the feedback, which is the number of rows that were modified, and I can look to see if my statement succeeded. When you're executing a query, the feedback is basically irrelevant. If it doesn't raise an error, the feedback can be ignored. And the next step, though, is that I need to retrieve the data from my table. So, I'm going to build and display the output. Again, a lot of this has to do with the formatting of my code. But let's go down to the main body of code, which is the loop. So again, I need to loop and fetch individual rows. So I call the fetch rows program to fetch a row of data, the next row of data. You can also fetch multiple rows and fetch into collections as an option with DBMS SQL. So I call fetch rows. I pass in my cursor, and it's keeping track of the location in the cursor. So I get my feedback, and the feedback basically says how many rows did I fetch. In this case, it'll be 1 or 0. So I exit when my feedback is 0. Okay, I got a row of data. Now, once again, I have to iterate through all my columns because I want to fetch the individual values. So while I've got another column, if it's a string, call column value, cursor, the index, and then retrieve it into a string variable. If it's a number, I'm going to retrieve it into a number variable. Date, retrieve it into a date variable. And then I'm going to construct the string of code that's going to be used to display it. And that's it. So I fetch until I'm done. Well, I've got a row that I still need to work with. I have to call column value to grab the individual value. So this is my into clause in my dynamic SQL statement. And as you can see, it's very dynamic. I don't hard code in advance how many elements I've got. Finally, for cleanup, the main thing is make sure you close your cursors. When I open a cursor in my local body of code with DBMS SQL open cursor, Oracle will not close that cursor at the end of my program unless I explicitly tell it to do so. So if it's still open, close that cursor. And that's it. I would say that's all, but that's a lot. So there are many different operations you have to perform. This is a relatively simple example of dynamic SQL method 4 and barely scratches the surface of what's possible to do with DBMS SQL, but it certainly should give you a good idea of the different steps that you have to follow. And again, the main thing is to understand this basic flow, and of course, check out the DBMS SQL documentation. Let's take a look at the other aspect of method 4, dynamic binding. So at the time I write my program, I don't even know how many placeholders I've got in my string. Since I don't know how many placeholders, which is a colon followed by a name, since I don't know how many placeholders I've got, I don't know how many expressions that I will need to bind into those placeholders. Therefore, I cannot use the execute immediate using clause because it's static. And instead, once again, I'll use DBMS SQL. It's much better suited, and in particular what I'll do is take advantage of the bind variable subprogram. Let's take a look. Here's my method for bind variables program. I pass in the SQL statement, whatever it might be. I pass in a list of placeholders. I pass in the corresponding list of values, and these are using a predefined array structure in DBMS SQL, basically a list of strings. I open my cursor. I parse my statement. So in this case, I'm assuming that there is no different columns that I need to define. What I do need to do, though, is bind my variables. So for every one of my values in my list, I'm going to call DBMS SQL bind variable, pass it the cursor, pass it the name of the placeholder, pass it the value. And again, bind variable is overloaded for the different types of data that DBMS SQL supports. Let's actually pull up the definition. Pull up the definition of DBMS SQL. So here's the DBMS SQL package again. Lots and lots of stuff. Wow. Here's bind variable. So notice there are different overloadings of bind variable for the different types of data: value number, value date, blob, b file, etc., etc. So that's partly why DBMS SQL is so big. It has to have all these overloadings for all the different data types. And as you can see here, you can also bind an entire array of numbers, an array of strings, an array of dates. So you don't have to bind individual values if you want to use bulk processing with DBMS SQL. So in this case, I'm using a very simple scenario. I'm passing in a set of placeholders of strings. So for every one of my values, I call bind variable. So there's my dynamic using clause. I execute my statement, and then I'll take a look at how many rows were modified by executing that statement. And then, some of you may have already realized, I left off a program, and that is, I need to close my cursor. So close cursor. Okay. In my example script, I've got a list of placeholders, a list of values. I find out how many employees are, or the sum of salary in the employees table for department ID is 50. And I'll display that value. Then I'm going to populate my placeholders with two names, salary and department ID, and values. 10,000 for salary, 50 for department ID. And then I'm going to execute my dynamic SQL clause statement. My apologies. Now this is not actually dynamic SQL, but I could have a variety of table names, column names, whatever the case might be. Assume that it's dynamic. Because what I want to show you is that even if I don't know how many values I have to bind in at the time I compile my code, I can take advantage of arrays of values, placeholders and values, to do all that work for me dynamically. And then afterwards, I'll see how many people are now, or the sum of salary now for department ID 50. And when I run this code, whoops, method for bind variables is invalid. What did I do? Let's see. Let's compile the program. And my message is, wrong number or types of arguments. Yes, that's what happens when you write code on the fly. I want to close my cursor, but what cursor am I closing? I need to tell it. Silly me. So let's put that there. Let's see if it compiles now. That's better. Okay, so when you close your cursor, specify the cursor you're closing, or Oracle will let you know. Run my code. No errors. Display the output. Before I did my update, the total salary was $168,000. After I did my update, total salary $450,000. Therefore, you can safely assume that there are 45 employees in Department 50. 45 times 10,000, 450,000. So it did the job, and it did it because I was able to dynamically, at runtime, sort through the number of placeholders I had and do my binding. Now, if I don't do all of them, for example, let's do a count -1 here, and I try to run this code again, I get not all variables bound. So when you're doing dynamic SQL, if you get this message, if you're using execute immediate, you need to go back to your SQL statement and compare the number of placeholders with the number of elements in the using clause. If you're using method for and DBMS SQL, then it's a little bit more difficult to track down the problem, but the bottom line is that all the elements, all your placeholders in your string, are not being matched up by values with a bind variable call. So what you want to do is look at the string that's being executed dynamically, and we'll talk about how best to do that under best practices, and then go back through your code that is generating the number of different bind variables and make sure that they match. So there's an example of method for dynamic SQL when you don't know the number of variables that you're binding in advance. Conclusions. Method 4, dynamic SQL, is relatively uncommon, but it's also very, very complicated. Most of the dynamic SQL operations you're going to face are situations with a little bit more certainty. I know how many elements I'm selecting. I know how many bind variables I've got. You don't have to worry about this level of complexity. You can stick with execute immediate. But because you know so little about the SQL statement you're executing in this case, you have to fall back on DBMS SQL. Then you get all the control you need, but wow, it comes at such a price. It requires a lot of code, lots of careful programming, lots of good debugging, and lots of good error handling. But the result is a very flexible program that can handle just about any requirement you've got.